Welcome to this video for Math 081. In previous videos, we've learned how to write the equations of horizontal and vertical lines, write the equation of a line given its graph, write the equation of a line given its slope and y-intercept, write the equation of a line given its slope and 1 point, and write the equation of a line given 2 points on the line. In this final video, we will learn how to write a linear equation to represent a real-world application involving rate of change. Let's get started. So this is a summary of what we know about the slope-intercept form. Remember that our slope is a rate of change, and the b, our y-intercept, is the initial, or let's write this down in our notes, the starting value. Another key thing to understanding or sort of dissecting these word problems is that this rate of change, if we're associating it with cost, it is usually a recurring value. And when we get to a specific example, I'll explain exactly what that means. And then the starting value is usually a one-time value. Okay, so please write that down in your notes, even if it doesn't exactly make sense right now. When we go through these problems, hopefully it'll make more sense. So again, when you are looking for your slope or your rate of change, it's usually a value that's going to happen over and over and over again because your slope is getting multiplied by x. And then your b is not getting multiplied by a variable. It's usually a one-time value, sometimes like a one-time cost. So let's do an example and see if this makes sense. So here's some steps that you can use. So we can define our variables. And notice that the last sentence in the problem usually tells you what the variable represents or what you're trying to find. Then we have to find the y-intercept, which is, again, the initial or starting value. We need to find the slope or the rate of change, which, again, we said is our recurring value. And then lastly, we put it all together into an equation in the form y equals mx plus b. Okay? So let's read this example. It says, Bob decided to give an allowance to his daughter, Cynthia. So as I read this, by the way, I'm going to go through and circle the information that seems important. Bob gives Cynthia $10 to start, and then he gives her $5 every week after that. Write an equation to express the amount of money Cynthia has, so that's going to be one of our variables, as a function of the number of weeks that have passed. Okay, so our two variables that we're going to need is the amount of money that Cynthia has, and then we need the number of weeks. Okay, so the amount of money as a function of the number of weeks. So the amount of money is going to be our y variable, and that's going to be a function of the number of weeks that have passed. That's going to be our x variable. And as we go through this, I'll try to explain more how I knew that one was y and one was x. So our y-intercept is either $10 or $5. So remember, the y-intercept is the starting value. Okay, and we're looking for something that is a one-time value or one-time payment, if you will. So which one, $10 or $5, is a one-time value? Well, hopefully you said that the one-time value is $10. So at the beginning, Cynthia has $10, so that means her y-intercept, or the y-intercept of this equation, is $10. She has $10 to start. He only gives her $10 once. After that, what does he give her? Well, he gives her $5. So this $5 is a recurring value because every single week she gets $5 more. So that's going to be the slope of our equation. Okay, so now we can plug in the slope, y equals 5x, and we can plug in the y-intercept 10. So this function represents how much Cynthia has after x number of weeks. So I said earlier that I would explain a little bit more how I knew that X was the number of weeks. And one way to understand it is if I make a little table. Right? So at the beginning, when no time has elapsed, Cynthia has $10. And then after that, she has $15 after 1 week, and then $20 and $25, and so on. So if I use this chart, then 0, 1, 2, and 3 are representing the number of weeks that have passed, and then my Y value is representing how much money she has. So that's another way that you can use to understand how we know that X needs to be the number of weeks and Y needs to be the dollar amount that she has. Let's do another word problem. So again, I'm going to go through and read this. As I read it, I'm going to circle what seems important. A phone company charges $3 for every gigabyte of data, and they charge $5 as a service fee. Then they ask us to write an equation that shows the relationship between the number of gigabytes and the amount of money that's charged. So we need the number of gigabytes of data, and then we need the amount of money that we're paying. And let's just, for right now, leave off which one is X and which one is Y. We'll just leave that as sort of a question mark, and then try to find our Y-intercept and slope, okay? So remember, your Y-intercept is your starting value, okay? And again, as you can see, these are usually involving money, so it's usually a one-time either income or one-time cost. So which of these, the $3 or the $5, is a one-time cost? Pause the video, make a note of your answer, and then unpause it and see if you were right. If you said $5, you were correct. So a $5 service fee is just a one-time cost. And so that means that our slope, which remember is our recurring cost, and we know it's recurring because we pay $3 not just once, but for every single gigabyte of data. So that means our slope is 3. And our Y-intercept, B, is 5. Okay? So we have Y equals mx plus b, and we can plug in 3 for our x, and we can plug in 5 for our Y-intercept. So now we need to go back and figure out, okay, well, what is x telling us and what is y telling us? Well, if I'm multiplying this $3 by x, then x must represent the number of gigabytes of data that I'm using. So x must be the number of gigabytes. And then that must mean that y, this total value, is telling me how much money I'm paying. So if I come back over here where I define my variables, this implies that my y value is the total amount of money I pay, and x is counting the number of gigabytes. And again, another way to understand it is if I were to make a chart here, x would be the gigabytes of data. So if I don't use any data, I just have a $5 service charge, right? If I use 1 gigabyte of data, that's going to be 5 plus 3, which would be 8, right? And for every additional gigabyte, notice I'm adding $3 to my total charge. So it makes sense that x represents the number of gigabytes and that y represents the total cost of my plan.